Hello guys, this is the third part of CareerWeekQuestionare SVMs. So the problem statement was we were presented with the dataset of digit patterns in which we were given the pixel values of each of the digits, and we have to correctly classify the digit which is from 0 to 9. So how are the images converted to features? Images were converted to features based on their pixel values. How can you briefly explain how SVM works? SVM works based on the soft margin classifier. These are the margins which try to classify the two different classes, and it lets some uh, data points to be misclassified, which is very unlikely from the perspective of maximal margin classifier. What is maximal margin classifier? We will see it in the next topic. What is margin and what is maximal margin classifier? Margin is nothing but the uh, enter distance between two classes, between the linear line that divides the two data sets or two classes. So distance between the nearest point of two different classes, the distance between that line and the two different points of those two classes respectively gives the margin, and maximal margin classifier tries to maximize this inter margin distances. So what are the support vectors? What are they called? Why are they called so? Support vectors are nothing but the soft margins which lets the some of the data points to be misclassified so that the model doesn't overfit, and hence they are called soft margin classifiers, and in other words support vectors as well, because they support the uh, model building process. Is SVM a linear model? Yeah, SVM is a linear model because it needs numerical data to be present for modeling. Can SVM work well on non-linear models? Yeah, SVM can work well on non-linear models as well, which logistic regression and cannot work on due to presence of kernels in it, which do transformation, feature transformation from the attribute to feature space, transformed feature space based on internal functions. So what are the advantages of using SVM for this task? Yeah, advantages of SVM for this task is it can handle non-linear data as well. It can handle complex data sets. It can be useful when there is computational overhead involved. What are the hyperparameters used in SVM? There are two hyperparameters used in SVM. One is C, cost parameter, that is the summation of all the epsilon values. Epsilon value is the distance of a point if that point is misclassified from the margin. So sum of all those misclassified sum of the distances of all the misclassified data points is the cost parameter. And sigma, another hyperparameter is sigma. The more the sigma value is, the non-linear the classifier is. So yeah, it increases the non-linearity in the model. One second. How did you tune the hyperparameters? We use the control train control method. in which cross validation function is used. We can set the value of CV attribute according to our need, and then we can use it so that the cross validation can work. And after cross validation we can provide the method what will be used in our modeling. So we can use tune.svm or train.fit function. One second. Yeah, we can use train function, either train function, or we can use tune.svm function as well. And in that we can provide the method value is equal to accuracy, and then we can provide the data, and the target variable is predicted with respect to other features. And we also provide the grid parameter values. In grid parameter values we provide the different values of sigma and different values of c, and we let the model to uh, decide which is the optimal value of sigma and c for our model. How can you briefly explain the cross validation algorithm? Yeah, cross validation algorithm breaks the data sets into different pieces, and we test our model on those pieces, so just to confirm that it is not overfitting the data set, the training data set on which it has been built upon. How did you evaluate the model? We evaluated the model based on the confusion matrix, based on the accuracy. uh, which other models do you try along with SVM? Yeah, first of all we try with vanilla SVM, that is the plain SVM for linear SVM, and a second one can be mm, second one can be RBF. Yeah, radial based function. One second. Yeah, these two models can be used uh, for modeling the SVM, and we can compare the accuracies of both those models and select the best model out of the two. How do you compare and choose between SVM and all other options available, such as decision trees, logistic regression, etc.? We try for all those models, and after building the model we look for other parameters as well, like AIC, BIC, uh, like accuracy, sensitivity, specificity in case of logistic regression, lift and gain charts, adjusted R square values, AIC values, uh, KS statistics. Which of these are linear models and which ones are non-linear? Uh, uh, Logistic regression, linear regression, SVMs, all of these are linear models. Yeah. Thanks, guys. That's all.